I've been an angel investor since 2000, and I've literally screened over 1,000 deals. And I have not seen a more effective pitcher than a nuclear physicist in Michl. He is incredible, and you'll see how infectious his energy is, and really why he has pushed and pulled this project through from the very beginning. So Michl, why don't we start off
Well,
with
thank you. No, I don't know if I deserve to be here, but with that introduction, I appreciate it, though. So I wanted to share a little bit about our past before we go into this to give you sort of a flavor of where we came from, and this is a perfect location to do it, given that this really originated out of the campus some now almost 30 years ago. We started this actually in 1989. Harry and I became friends, what, about sometime mid-90s maybe? Right?
I think mid-90s, I think early 90s.
Early 90s, perhaps even. And then 20 years as a real company. So in fact, in 1998, when we began, we had a thing we called the sewer pipe. It was actually a university project scale. We drew it up on a napkin over lunch and then built it in a few weeks with a few students. And that migrated over the last 2 decades into ever more sophisticated national lab scale machines. In fact, we're operating now, what you see there highlighted in yellow, we call it Norman, because Norman Rostocker, my PhD mentor and one of the top people in the field, a faculty here in the physics department, deserves all the credit, really. He's the brainchild behind literally everything we've been doing. And this machine is getting us now to the proof of science stage. And so the complexity of this is now way actually beyond national lab scale. In fact, this is the largest, most modern fusion machine in the country. And as Richard said earlier, it's fully privately funded. No government support, no down round. This was all done on private equity placements through the years and scaling this up. And what we're really going to be in the next couple of years is actually the ability to actually make net energy. And that's going to happen in a machine we call Copernicus. And we're in the process of funding and putting that project together right now. We're working actually for the first time with the UE in some form of relationship where they're going to contribute some in-kind. And this will be a sort of public-private partnership to pull that off. And then it goes to commercialization. So the notion that you hear fusion is another 20 years away, 30 years away, 50 years away, it's not true. We're talking commercialization coming in the next 5 years for this technology. And more importantly, when you look at the evolution of this, there's a ton of technology that enables that. It's just like when NASA went to the moon and developed lots of stuff. In order to do these kinds of sophisticated devices, there's just an incredible spectrum of technology and sophistication. And as we matured our main goals, we had to mature the speed technology to support that. And that led ultimately now to a terrific portfolio of opportunity that we're in fact commercializing today. And so in fact, this last year is the first year for us where we're, instead of just only bringing investor dollars in, we're actually harvesting the fruits of some of that labor. There's multiple spin-offs that we're pursuing. The 7 trillion opportunity in fusion, of course, is center and foremost and is the driver. But there's a life science unit, which we spun off last year, which raised 40 million last year for an A round. It's doing very well in a very novel cancer treatment. We're actually also talking to the campus deploying one of these machines. These are actually going out now. The first one is going to go in China next year and start clinically treating people with diffuse cancers with a technology that comes out of our beam accelerators. TA Mobility is something I'm working on this year. This is a company that's going to really revolutionize the electric drivetrain. Think taking the current batteries and motors and all the components, but put smarter software and smarter electronics together derived out of our power supply developments. And that's going to enhance the drive range of cars by about 30%, give you another 40% of power and performance headroom. And ultimately will allow us to build more cheaper and more compact electric cars and help the evolution in that sector, which of course is massive. And then there's evident work we're doing in beams generically because it supports all these things. So TAE today migrated from just fusion-centric to fusion being the focus, but a broader portfolio of things. And with that comes the opportunity for a sort of staged set of what I would call return on investment or influx of capital other than through the usual past of ours in terms of real